everybody, and welcome. Welcome to our Towards Net Zero webinar series. This is Renovating for High Performance. You're in the Above Grade Walls, What Are the Options webinar. We're going to allow 1 minute for everybody to join in the room, and then we'll get going. All right, I'm just going to move on to the housekeeping. We're going to slowly get into this. So in this webinar, what we ask is that you put all of your questions to the panelists in the Q&A. Only those in the Q&A are actually the ones that we're looking at to pose to the speakers during the webinar. The chat is there for you to engage with your colleagues and give us some information about where you're from and all of the background. But please make sure that your questions go in the question and answer. Be considerate, respectful. And there will be a survey afterwards where we're going to ask for some information about what other things you would like us to talk about on this topic. There will be links, and the presentation will be sent to you after the webinar. And so we'll get going. So my name is Lynne Strickland. I am the Director of Net Zero Initiatives with the Canadian Home Builders Association with our Net Zero Housing team. And on my team, I have Lori Howe, who is our Net Zero Administrator, and Brendan Fraser, who is our Technical Analyst, who has been running all of our renovation case studies. And we have been working with Building Knowledge since the beginning as our lead consultant, with Andy Oding, Toby Smith, and Kimberly Cobb as our webinar team as well, but also throughout all of the endeavors that we've taken on through this initiative. So this is a 5-part webinar series that is part of the final 6 months of this 4-year initiative. So we, again, have been working with Building Knowledge, but we also have a Net Zero advisory group. We've been working with municipalities as well as our home builders associations across Canada and our project teams. So the 5 series, we've already had one at the end of October. You're in the Above Grade Walls. They are all interconnected. And these are just the top 5 that we really focused on. So we really invite you to join them all, and we'll be having another QR code at the end of the webinar that you can also sign up with. So the initiative. This initiative has been going since 2022. We've engaged with 13 municipalities across Canada from the Yukon, BC, Alberta, Saskatchewan, Ontario, Nova Scotia. And what we have is around 350 residential units that are represented. And what we're hoping to convey today is some of those lessons learned, some of that information and key details, not just on the building science side, but also on the business side. How does this actually roll out for you as a renovator? So the distribution has been over a third have been single family homes, but then we also have townhomes and multi-unit residential, and a couple of duplexes and semi-detached. So in this webinar, we are really pleased to have quite a spread of expertise and knowledge. We have Trevor Trainor coming from Bawating Building Science, Gord Cooke from Building Knowledge Canada, and we have renovator teams talking about their projects. Chris Smith from Woodsmith Construction, Peter Darlington from Solar Homes, and we also have qualified net zero energy advisors on all of these projects. But Toby Smith from Building Knowledge Canada is not only a master energy advisor, but has also been our program manager for all of the energy advisors throughout this initiative. So I'm putting this quote up there from Avery Lovins in that the cheapest, cleanest energy is the energy you don't use. This ties in with our CHBA Net Zero Home Labeling Program and the premise of envelope first. There are aspects where you can do fuel switch outs and you can achieve energy reduction and you can achieve GHG reduction. But in terms of the long-term plan, the roadmap to net zero, it is really critical that we deal with enclosure first in that plan. And this is where we see the greatest savings in terms of dropping that load and then managing the mechanicals after that, which is our next webinar. But this is where we're going to really dig into how we get that envelope, that enclosure optimized for your clients. So we're just going to reach out with a couple of polls to find out more about you, our audience. and then we'll go forward. So Kimberly, if you can pull up the first poll. All right, so where are you located? We're hoping to get as much of a spread of attendees as we do from our projects. And yes, if you are from anywhere outside of there, please do jump in the chat and let us know where you are. Should we start seeing some of the results? All right, half from Ontario, not surprising, but we do have representation from Atlantic provinces, BC, Alberta. We don't have anybody from the territories this time. We'll have to reach out next time. All right, let's go forward and see what part of the industry, the renovation industry, do you represent? It really helps in terms of understanding the perspectives of the attendees that are coming to the webinars, but it also helps us in terms of tailoring some of the information that we want to send out. And again, if doesn't fall in with any one of these, do let us know in the chat. All right, let's see who's in the room. Oh, a nice spread. Oh, excellent. Excellent. Okay, so this is a nice broad spread, so that's wonderful. All right, so we're going to move now and we're going to introduce our primary subject matter expert here. So we've got Trevor Trainor, who is the president of Bawating Building Science. And Trevor came with us when we went up to Whitehorse and we were doing training up there, has a breadth of knowledge on enclosures in multiple climate zones. So being based in Southern Ontario and having experience all through Canada, we're really lucky to have Trevor on our panel today and as our subject matter expert. And joining Trevor and adding commentary as with the insights that Gord, having such a vast amount of experience and knowledge in this field and being very familiar with all of the players in this room, being able to offer some guidance there. So with that, Trevor, I'm going to turn over, and our project teams who will be coming after, and then we'll be kicking off with Trevor right away.
Great. Take over here.
And while Trevor's just getting set, I'll say, Lynn, thanks very much for the opportunity. I'm just scrolling down the names of some very familiar faces, sorry, at least names on the screen. Zoran's always at the end of the list, the Z for Zoran. Hi, Zoran, how are you? And Ben Van Hove, I was just talking about you today, Ben, with somebody you would know. So just wanted to say hello to folks. And so pleased to be working with Trevor on this. Are you set to go, Trevor?
Yeah, all set. Thanks, Gord. Thanks, everyone, for joining us today. This is a really fun topic for me for a couple of different reasons. Just to introduce myself quickly, my name's Trevor Trainor. I'm the president of Bawating Building Science. I established Bawating Building Science about 3.5 years ago to focus on Indigenous housing issues. And one of the things I've been working on a lot are renovation strategies and remediation strategies for housing in the Arctic. And so I've been doing a lot of design work and research and collecting data on the performance of wall and roof systems in Nunavut, so in a very extreme cold environment. And so it's really a great testing ground to test out all of the concepts that we're going to talk about today. And then on top of that, I've spent the last 2 summers working with my son on our house in Stratford, Ontario, doing a complete exterior insulation retrofit, as well as electrification on our house also. So a lot of coming at this from a lot of different angles and a lot of different perspectives. And I think there's some things that are really interesting to talk about here today. So first of all, in terms of net zero ready renovations and just renovating and fixing up our old houses in general, there's a lot of opportunities out there. So we have over probably 900 million, or sorry, 9 million existing detached dwellings in Canada. And 50% of those are over 60 years old. And 20% of them are over 80 years old, like my house. Residential energy accounts for approximately 18% of our greenhouse gas emissions. So there's a big opportunity there to improve that. And we can make a significant impact on energy consumption, greenhouse gas emissions, and economic development by fixing up these houses that already exist, many of which have really good structure and bones to them. And we'll talk about a lot of the details of how to do that. Also, the great thing about working on the building enclosure in an energy retrofit is that we have the opportunity to improve other areas of the building, including water control and air tightness and other issues that are related to the durability of our homes. So not just improving the energy performance, but also improving the moisture performance and the durability of the buildings that we live in and extending their lifespan. There's also a lot of challenges, though, when we're working on renovations and trying to make old buildings much more energy efficient. First of all, the price of housing today and the carrying costs, because of that, many homeowners have a difficult time justifying the upfront costs of energy retrofits. Some of the programs that we have available are helping. I certainly tapped into some of those, but I think there's a lot more that can be done from the government perspective of incentivizing this work. Existing buildings are also just really unpredictable. Until you open them up, you don't really know what you're going to see. This is a great example of my house, where the previous homeowner had poured spray foam from the inside into the empty stud cavities and a lot of the gaps and things we found while doing that. And able to fix those up by doing an exterior insulation retrofit. But there's a lot of surprises along the way, and that's got to be expected when we're working on old houses. The other thing is too, as a challenge, is that prescriptive technical solutions are really difficult to develop because there's so many variations in the houses. We can't just give one answer in many cases to how do you do this. So it's much better to talk about the strategies and the building science principles behind these things to really help develop the industry, as opposed to just giving a solution that's supposed to work in every circumstance. And lastly, the industry, we just have a lack of capacity in many ways to undertake deep energy retrofits. It's a different set of skills in some cases than new construction. And we need to develop those skills as we're starting to do with programs like this today. Yeah, my slides aren't progressing very quickly here today. Let's see. There we go. I jumped ahead. Okay. So today we're going to talk about wall systems specifically for the Net Zero Ready program. And if you're anywhere in climate zones 5, 6, or 7, so from this yellow zone south, which is probably most of us, if not all of us today, what we're going to be shooting for is a effective thermal resistance of 17.5, R17.5. And we'll talk a bit more about effective R values versus nominal R values and ways to achieve that on some of our existing buildings. Okay, yeah. Slides are jumping. So we're going to go and talk a little bit about the different archetypes that are out there in terms of houses that are existing. Definitely there's, especially in our big cities, there's a lot of houses that are pre-World War I, these double brick and triple brick buildings. Also like the post-World War I, where we were kind of transitioning from load-bearing masonry to wood framed and some of the challenges that come with that we'll talk about. Post-World War II, that's probably the biggest housing boom we've had in Canada. That's Actually, no, it's the second biggest if we look at this chart, once they started actually looking and measuring these things. And so there's a lot of wood-framed post-war houses in a lot of communities in Canada, usually on streets called Victory Lane or Normandy, something like that. And so as the soldiers came home from World War II, there was quite a big boom of small, simple houses that were built, most of which were wood framed, some of which were block framed, concrete block, but we'll get into how to fix up all these different types. A larger boom we saw in the 1970s, which I guess is the baby boom, which is when the baby boomers started buying their houses. And there's a lot of pretty much entirely wood frame housing at this point, mostly 2x4 construction. And then finally, the ones we're going to talk about today are the 80s and 90s, which would probably be the newest houses that we'd ever get into in terms of doing deep energy retrofits. And as we got through the 80s and into the 90s, we're talking about 2x6 wall construction, actually vapor barriers involved and things like that. So some of those strategies are going to change depending on the wall archetypes that we're going to look at. Okay. So let's look at some different strategies for these different archetypes as we go, and sort of practical ways in which we can get these existing walls up to the standards that we're looking for today. The important thing to think about as we're working on any part of the building enclosure, whether it's walls or roof or foundations, is to really understand what the building enclosure is and what its functions are. So when we talk about the building enclosure, we're talking about above grade walls, which we'll be talking about today, but also sometimes we'll be talking about roofs or foundation walls, floor systems, and even windows, which I think is another seminar unto itself. And then the other important thing when we talk about the building enclosure is what the function of the building enclosure is. So there's the structure, right? There's either the wood studs or the brick, double brick structure that's there to hold up the roof and keep the thing standing. And then the other part of it that we really need to consider when we're renovating, which are the control functions of the building enclosure. In order of importance, those are water control, air control, thermal control, and vapor control. And so as we go through some of our examples and some of our approaches, we want to really think about how are we addressing these 4 control layers. So the first wall archetype we're going to talk about, this would be houses for definitely pre-World War I and some of the post-World War I houses, which is load-bearing masonry. Double or triple wide brick is the most common. There's some stone out there also, but I think a lot of what I see in my community and when I'm working in Toronto, for sure, in some neighborhoods, is a lot of double wide brick. So the important thing to remember when we're working on a load-bearing masonry building, as opposed to a wood frame building, is that when we make changes to the building enclosure and the wall system, we're changing how this system behaves. So let's look at this in a couple different ways. First, let's look at the thermal performance of an existing, in this example, it's just a triple wide brick wall. It's about an R4 we get out of this wall system, which is about 1.1 watts per meter squared K of heat loss we're gonna see. The other thing to look at is how the temperature changes from inside the building at 20 degrees to outside at -10. All of the temperature drop occurs across this structure in this case. And we'll talk about why that's important as we get into the strategies of renovation. The other thing on air tightness, so every wall needs those functions, right? So what's the air tightness? What's providing the air tightness function in this kind of wall system? I mean, it's the brick in general, but more importantly, as I found in several projects, it's the interior plaster that was installed on top of the brick as the interior finish. And anywhere we penetrate through that plaster is really a risk for significant air leakage. So something to keep in mind. They were really counting on You know, I don't know if it was intentional or not at that point from a design perspective, but really counting on that plaster layer to act as an air tightness barrier.
And Trevor, I'm sure you've had the experience. I've measured houses where they were old houses, but surprisingly
Yeah.
airtight because of the consistency of that plaster layer.
Yeah, my house was surprisingly airtight because of that too, even before I did my renovations. So that's a good point. And then how does a load-bearing masonry wall deal with water, right? There's no house wrap on it. There's no siding on it. Really what we're doing is creating a system that can absorb water and hopefully absorb and store enough water that it doesn't leak through. And then give it the ability to dry out afterwards. So this is how these systems work. If water hits the brick during a rainstorm, it gets absorbed and stored, hopefully safely without draining to the inside. And then when the weather changes, it gets warmer out, drier out, it can dry to the outside. And as long as we're not loading more moisture into the system than it can handle in storage, we don't have any problems. And that's how those systems have worked. I think if you start to do renovations on buildings like this, you'll start to notice things like some moisture damage under windows and other areas of exposure, like around chimneys. But for the most part, the system worked in that the walls were thick enough to absorb that moisture, store it, and dry it out. And then the other thing that's really unique about masonry wall systems is the fact that they're vulnerable to freeze-thaw damage. And this becomes really important as we talk about how we're going to renovate our buildings. So the formation of frost and the expansion of liquid water within the pores of a brick or a stone or in mortar can result in high internal forces. And these forces can cause structural deterioration of the materials. So the result in chipping or crumbling of the brick. This is my house. This is the front corner where there was a downspout that was leaking for a little while. But I think more importantly, what happened here is that the previous owner had spray foamed the rim joists, which are right behind this zone, without thinking about the consequences of doing that. And we're going to talk a lot more about, you know, sort of those consequences and trying to avoid unintended consequences during our renovations. So for freeze-thaw damage to occur, two conditions have to be met. The material has to be below freezing, actually quite a bit below freezing, probably about -5 by the time it affects the brick. And the material has to be sufficiently wet. If those two things happen at the same time, we start to get damage. What does sufficiently wet mean? Really, it depends on the brick. A really durable brick can be very wet and still survive a freeze-thaw cycle. This brick is probably on the low end of, on the high end of susceptibility, and so that's why we're seeing this deterioration. And so it's good to understand the current condition of the brick when we're talking about renovating an existing brick building, to understand when we change it, is it going to make it worse? Is it going to push it past sort of the tipping point of freeze-thaw damage? So as we change buildings and as we add insulation to them, we're going to change this heat flow dynamic. So I showed you this before, how the temperature change occurs across double or triple brick wall with no insulation. Now let's add insulation. If we add insulation to the outside, okay, we're doing a couple things. We're slowing down the heat loss considerably, right? Down to about 1/3 just by adding R10 on the outside. Reduce the heat flow by about 1/3. But we're also dramatically changing the temperature profile in the brick itself. So the brick is much warmer than it was here, especially as we get to the outside. And that's really important in reducing our risk of freeze-thaw damage. But let's say we don't want to put insulation on the outside. We want our house to look like it does now with brick on the outside, and we add insulation to the inside. Well, it has the same effect on heat flow, right? We've reduced our heat flow by about 2/3. But what it really doesn't change a lot, well, it does change, but in a negative way, is the temperature profile across the brick. So now the brick is colder through more of its depth, and it's even a little bit colder on the outside surface than it used to be because of the lower heat flow that's going through it. So because of that, we have to start thinking about and worrying about freeze-thaw damage on the exterior. It also changes the moisture flow dynamics. So we talked about how the brick wall could absorb and store moisture before. If we do an exterior insulation retrofit with new cladding and we add a new WRB, whether it's liquid applied or a peel and stick membrane, we're completely cutting off the moisture flow into the brick, which keeps it dry, which reduces its risk of freeze-thaw damage. If we add insulation to the interior, we still have all the same dynamics from a moisture perspective in terms of how much moisture is getting to the wall, being absorbed into the wall, except now the wall has less ability to dry because there's less heat flow going through it. So by adding the interior insulation in this case, we are making those bricks stay wet for longer. And we also know from the previous slide that they're going to be colder for longer. And so we have to be really cautious about freeze-thaw damage. So those are the concepts. Let's talk about some of the realities and some approaches that can really work in this situation. Yes, the drying potential is to the outside. Sorry, I just saw a question come up. The drying potential is to the outside, but because there's less heat flow moving through the wall than there used to be, there's going to be less drying capacity for that wall system. Okay, so let's look at a couple approaches that work really well if you're willing to do and interested in doing insulation on the exterior. The first is an EIFS retrofit, and the second is an overcladding retrofit. And they're both very similar in performance. A few different steps are required. For the EIFS retrofit, we have to repair the damaged bricks and mortar, clean the exterior surface, install a liquid applied air barrier and water barrier, and then apply our EIFS insulation and coating system. So that's pretty standard approach for EIFS. Very similar approach for an overcladding. The difference being we're going to have some type of strapping or clip system that's going to penetrate through the insulation back to the structure and support our cladding. So some of the things that are really good about this approach, just to note too, we need to add about R16 to the exterior in order to get our effective R value above 17.5. Couple of upgrades that we're doing to this wall system is not just the energy and heat flow, but also a new air control layer in this air water barrier and a new water control layer. So a couple of really big benefits of doing it this way. The bricks stay warm and dry longer. We limit thermal bridging. All the embedded wood that's in there, and we'll talk a bit more about that, stays warm and dry. All of the work can be done from the exterior, which can be a benefit if the home is to remain occupied during construction. The drawbacks being we lose that historic facade. It may cost a bit more than doing the interior. That depends though, it may or may not. And it could be a drawback that all the work's being done from the exterior because especially in some neighborhoods in large cities, access to the sides of these buildings can be really challenging. It might be hard to get scaffolding up the side of this building.
And Trevor, that's really the essence, isn't it? Is this aesthetic and access concern versus the thermal. I just want to highlight the reason this series is being done is to avoid those unintended consequences. From a thermal perspective, just insulating on the inside meets the thermal perspective, but from a total durability of the building, you really would rather insulate from the outside. So you want to try to make that compelling case to your designer / homeowner / municipality, maybe the neighborhood community, that we are really better. This is a beautiful historic old home. People say I'm losing the historical look. Well, what was important about this building? Was it the brick or was it the historical design of, or maybe the context of what's inside, and help people understand that just because I'm covering the brick doesn't mean I'm taking away from its historic significance. And if I really want that structure to last, another 200 years,
Yes.
really would like to be from the outside.
Yeah, that's a great point. And then there's always those construction challenges too, right? If you don't have room to put scaffolding because your house is 3 feet away from the neighbor's house, how do you attack that from the outside from a renovation standpoint? So that's why renovations are so challenging. There's so many factors involved. But certainly if we can do these masonry, like load-bearing masonry retrofits from the outside, the durability factor is going to be a major benefit. But many cases we can't, so we have to do it from the inside for different reasons, many reasons. And so let's look at a couple ways we can do that. The first is what I call a spray foam approach. And that's using about an inch, about R6 of spray foam against the brick. Optional, I say, but we'll talk about it, is to install a bond break layer. So I'm recommending this to all my clients, is to put a layer of house wrap against the brick to spray foam against. And it's also the spray foam is also being held in place by the wood stud wall that's inside of here. But I do that in case this ever has to be deconstructed. And because of the risks we're talking about in terms of freeze thaw damage, that's something that could happen. If we do this renovation and then 5 years or 3 years later, we start to see damage occurring on the bricks on the outside, we need to be able to reverse that. And so that's why I'm recommending that. It's not for a functional perspective, but for deconstruction. And so in this approach, we put, about 1 inch of spray foam minimum directly against and continuously against the brick, and then a stud wall with R14 bats. That'll get us our effective R value that we need of about 18.8. So the benefits of this is that we're getting our new thermal control layer, right? We've increased the efficiency. We're getting a new air control layer too with this spray foam, which can be a benefit in terms of air tightness. But where we're not improving our house too much is we're not really improving the water control layer. We're still counting on this brick to absorb and store safely that moisture, and we're reducing its ability to dry out a bit, so we have to be careful there. So a couple of benefits of the spray foam approach is, readily available materials and trades. It's easier to transition at foundations and roof. We can talk a bit more about why that's harder to do without using spray foam on the inside. On the outside, though, it can be really easy to do. But once we're stuck to the inside, spray foam makes that easier. Can be more cost effective. All the work can be done from the interior, as we talked about before. The drawbacks of this approach: bricks will be colder and wetter than before, so we have that risk that we're driving up in terms of freeze thaw damage. Embedded wood will be wetter than before. We'll talk a bit more about that. The risks associated with spray foam in general, because we're manufacturing a building product inside of a house. There's some risks associated with that. Is the temperature appropriate? Is the moisture content appropriate? Is the humidity appropriate in the building to do that properly?
In fact, it came up in the question that the spray foam has fairly high carbon impact. And so certainly we might need a different solution. So some of the board stock foams, as you had mentioned, either spray foam or you could put a sheet foam back there that might have a lower carbon footprint. Yep. There is an interest, of course, in making that layer, that the attributes of foam in that layer, that you can find other ways to meet it, but foam has some really good properties in that.
Yeah, in terms of sealing between the wall and the foundation, the wall and the roof, it really has a lot of benefits from that perspective. Right. On the other hand, there's a lot of people who don't want to use foam products at all. And so I want to talk a bit about a foam-free approach. Quick question: how does this affect interior area? Yeah, that you're going to lose some floor space anytime we do these interior retrofits.
I'll just remind people, put your questions in the Q&A, please, not the chat. It can be a little distracting.
The chat pops up on my screen.
Yes, thank you.
Gotcha.
So put your questions Q&A. We'll get to all of them.
Okay, great. And so a lot of people don't want to use spray foam at all. And this is a very, especially in the passive house community, this is a more I call a foam-free approach. And basically this involves installing a vapor closed liquid applied water barrier to the inside of the brick, adding a continuous layer of semi-rigid mineral wool insulation, and then a stud wall with more bad insulation. And this is the big one here, is installing a smart vapor retarder / air barrier on the face of that, then strapping, and then drywall. And the reason we're really pushing for strapping and drywall here is to have, as we don't have electrical outlets and other things penetrating through this air barrier, because this air barrier is really important in this assembly to avoid air leakage condensation and adding more moisture into the brick we're trying to avoid. So system upgrades, so things we improved, obviously the thermal control, we did a good job of that. If we have R4 and R14 bats, it's going to get us to an effective R value over 17.5. We've got a new smart air barrier and vapor barrier, which we can use to improve air tightness, which is good. But we haven't, again, really addressed this water control. What we have done is put this water control layer back in here to avoid any moisture from the brick wall getting into this cavity, because if any of this water is driven in through vapor flow or capillary action into this wall system, it's going to be trapped there for a long time, and there's going to be a lot of issues that we could have related to mold, rot, and decay that we want to avoid. Similarly, the air tightness of this air barrier is really important, because if we have air leak into this space, it's going to find the cold back of this wall and form condensation, and again, build up of moisture in this wall that we're trying to, we need to avoid. It's less of a risk when we use that spray foam or the board foam products against the foundation or against the brick wall directly, because it's not permeable to air. Let's see. Oh, there we go. Okay, so the interior, the foam-free approach, the benefits: no spray foam, no petrochemicals. Easier to transition in some places, like at the ceiling, if you've got if you're using a flat ceiling anyways. All the work can be done from the interior. The major drawbacks, and the ones we're really worried about, is the bricks will be colder and wetter than before. The embedded wood will be wetter than before. It's more difficult to transition at foundations and at penetrating floor systems from the first floor to the second floor. This risk of air leakage condensation we talked about, that air barrier has to be really good in that approach. The materials and the trades are less available to use this kind of approach. I know it's harder to find people trades that have done this approach before and know how to do it properly. Okay, so moving on to the next wall archetype, which is going to be a lot more simple than what we talked about earlier, are all of the houses that have 2x4 walls. That's going to be a large chunk of the houses we work with. So anything post World War I, a lot of those are stick framed with 2x4s. My house was, even though it had brick cladding, it had balloon framed right from the foundation to the roof. Anything post World War II and into the 70s for sure will have 2x4s structure. So in this, we could have any sort of combination of brick or siding. There may be building paper or some other type of house wrap back there. There may not be, depending on where we are in that time frame. Probably not any polyethylene as a vapor barrier on the inside. Mostly using an interior plaster, again, as the air barrier for most of these. Into the 70s, we start to see poly, but definitely less so post-World War II and before. And then there may or may not be any insulation inside these stud walls. I know my house, which was built in about 1924, I believe, completely empty cavities until the homeowner before me poured in that that spray foam that we could see in that photo. Later, though, into the 70s, we'll probably see some R10 fiberglass, some pretty rough fiberglass in terms of working with it, if you've ever worked with it before. Some of them seem like they actually threw some shards of glass in there for you to work with, but it's definitely into the 70s, we start to see them filled with fiberglass at least. So what are a couple approaches that'll work for this situation? We've got a 2x4 wall. Whether it has insulation in it or not, we could do two things. We could remove the insulation that's in that stud cavity or fill it, if it's empty, with R14 and add a new air vapor barrier on that surface, then add R6 of insulation to interior of that. And that could be rigid mineral wool. It could be a little stud wall, or it could be foam board, depending on what you want to do. But basically the combination of the R14 bat, which would be new, and the R6 would give us an effective R value over 17.5, which would meet. And we also have the opportunity to add this new air vapor barrier into the system, which could be good, a benefit to that. If you want to keep that R10, if your house has R10 bat insulation already in the 2x4s, you want to keep that, we'd still recommend you rip off the old drywall or plaster, put a new air vapor barrier in, and then add a stud wall with R12 bat, which would give us get us up to R18.3. So again, over 17.5 to meet the needs of the program. So a couple of things when we do this, we've upgraded our thermal control, which is the main goal, but we've also have the opportunity to add a new air vapor barrier, which is good. We're working from the inside, so we're really relying on the existing water control, the siding and whatever was out here to keep water out. And so that's one drawback to working from the interior in this way. So if we wanted to do it from the outside, we could certainly do that. Oh, sorry. Quickly though, benefits for adding interior insulation. We're going to reduce thermal bridging, which is good. We have the opportunity to add a new air barrier. We can retain our original exterior finish if that's a goal that we want to do. The new cavity can be used for mechanicals, potentially, to avoid penetrating through that new air vapor barrier we put in. Some of the drawbacks, there's going to be some risk for air leakage condensation, so we really need to make sure we do a good job on that air barrier, because we've got that insulation that's air permeable now in the wall, and we have cold sheathing. We're going to lose some floor space, right? So the whole thing's going to, we're going to lose a ½ inch to, well, no, about 2 to 4 inches of floor space all around the building. We're also relying on the existing water control. So we have to be pretty sure that the exterior water control is working well and that we don't have any leaks, because they're only going to get worse once we add more insulation in terms of how much moisture accumulates and how much mold and rot can occur. So the other thing that we can do with this is add exterior insulation. So if we did want to replace or put in our empty cavities R14, if we add R6 insulation to the outside, that's going to get us above R17.5. If we wanted to keep that old R10 insulation that was in there, we'll have to add a bit more. We'll have to add about R10 insulation, exterior insulation. And this could be foam board. This could be rigid mineral wool. There's definitely some options for that. So in this approach, a couple of things that we're upgrading in this wall system. We're adding our new thermal control, so we've improved the energy efficiency of the system, but we've also have the opportunity to add a new air barrier to the outside. So we can now use our house wrap as an air barrier, seal it appropriately, and transition it appropriately. And so that also gives us a new water control layer. And so this is a really significant upgrade, both in terms of energy, but also in terms of water management and durability. By going from the outside, we have more of an opportunity to improve water control and improve air tightness. Some of the drawbacks of adding exterior insulation is we've got to replace the siding. So all new siding or cladding, all the work has to be done from the exterior. As we talked about before, that could be a challenge depending on access. But we have the benefits of a new WRB and a new air barrier. The big benefit too is reducing the condensation risk inside of our walls and minimizing thermal bridging. And then the last archetype we'll talk about real quick is a 2x6 wall. So there's probably going to be rare, but we might get into 2x6 walls that we're trying to bring up to net zero energy standards. Typically those would have, R19 bats in them, maybe R20, depending on exactly when they got installed and how the industry was changing at that time. But there's a couple of approaches we can use. One, we could just take the old insulation out and replace it with R24 bat insulation. And that'll get us to the effective R value we're looking for. So that involves removing all the interior finishes. But it also does give us an opportunity to put a new air vapor barrier on the interior and improve the air tightness. Again, in this approach, we're relying on the old water control from the outside. So we have to make sure we're really confident that there's no leaks from the outside, no water getting in from the exterior, or we could have water damage, and it could be worse even than it was before because we have more insulation, less heat flow, less drying capacity. So some of the benefits of re-insulating, improving our bat insulation and the performance of our bats. We can add our new air barrier. We can retain our exterior, right? So we don't have to add new siding. If we like the brick cladding, that can stay. Some of the drawbacks. Oh, sorry, jumped ahead. There we go. Really limited performance upgrade, just going from R19 to R24 bats. That's a lot of work to do that small jump. We still have that risk of air leakage condensation, so we have to make sure that our air barrier is really well done. And now we have to replace all the interior finishes just to go from R19 bat to R24 bat. So that's pretty extreme, but it does meet the requirements of the program. And then the last one we'll talk about is adding exterior insulation to an R19. Assuming there's R19 bats, we'll need R4 exterior insulation. This also gives us the opportunity to add a new WRB, and we could detail that as an air barrier and improve the air tightness of the wall system at the same time, which also has some benefits. One thing, once we start getting into 2x6 wall with exterior insulation, we have to start worrying a bit about our insulation ratios. How much insulation is on the outside versus the inside. Assuming we're using foam board insulation, we have to, at minimum, meet the requirements in NBC table 925.5.2, which for the climate zones, well, if it's climate zone 5 or 6, we need to make sure that the insulation ratio is at least 20% on the outside. If we're in zone 7A, at least 30%, or sorry, 30% is on the outside.
And I'll just remind folks, Trevor, that's for low permeance.
That's if you're using foam board insulation or low
so
permeance.
if you use a vapor open material insulation on the outside. And I think you'd agree, I know in this case, Trevor, you were showing kind of meeting the minimum requirements. I think you agree, the more the merrier on the outside, right?
When it comes to exterior insulation, even this table is based on not making the wall worse than it was without exterior insulation,
right.
Not making it better.
Yeah.
So yes, the more we can add,
right.
In terms of moisture.
Yeah, if you're going an inch, go an inch and a half, right? Like
right.
Yeah.
At that point, the material cost isn't your biggest cost, really. It's going to be the labor and the approach.
Thank you for accommodating me there.
Yes, no, that's a good point because this is bare minimum. More is better in terms of both energy, heat flow, and in terms of moisture durability. And then finally, really important, we talked about, we've looked at these walls as just a two-dimensional sort of wall, but really the key to success in these projects is getting the details right. So it's designing and executing the building enclosure details. So the details have to be developed to assure continuity of the water control, the air control, the thermal and the vapor control layers. And continuity can be really challenging at penetrations and transitions, where one enclosure element meets another. So where the wall meets the roof and the wall meets the foundation, where the wall meets the windows. These are all really key details. And I'll show you quickly, how are we doing for time, Gord?
About 5 minutes or so left.
Okay, perfect. That's
Because we'd like
perfect.
to do a few questions. Yep.
Okay, I'll really quickly just go through some examples without getting into too much detail of some details that I've developed for some other projects recently. So here's what I developed as a detail for an interior spray foam free insulation retrofit of a double brick house. And you can see there's a lot to it here. But the important thing is that the air barrier is continuous and transitions to the windows. How the windows attach and get installed is a whole other challenge in terms of where they sit. In this case, we chose to put a plywood buck that is completely wrapped in the air barrier. And then the final transition between the air barrier of the wall and the window frame is a continuous bead of caulking on the interior. On the outside, water control is a little more difficult in these, especially in double brick, because we don't have any one thing to tie into. So we have to be a bit more careful in how we detail that. One of the key factors always in any window install is having a sill pan flashing. Somewhere for the water that gets around or through the window and starts to collect below the window itself, have a way for it to get to the exterior. And so these are the kind of details that need to be developed for a given project to really assure its success. And this is just one example for a window. Here's a window example for an exterior insulated wood framed wall system. A little simpler, but now our water control layer, for example, is back behind our insulation, and we need to make sure that it transitions out to the exterior and that water's directed above the windows out and kicked out with a flashing. Similarly, at the base of the window, we need that sill pan flashing and a way for the water to drain out from below the window and to be on the proper side of our water control layer. So
These
depending
details,
on,
These details are worth the price of admission alone.
The problem being these vary so subtly from project to project that it's hard to just apply an old one to a new project. But
Right.
you kind of get the intent here. Again, the air barrier system on the inside in this case ends up being transitioned to the window with a bead of caulking. All of these things and elements of continuity can be worked out in these cross sections. Doing them, executing them on site is a whole other challenge, but I often work with the builders on the first day that these are being executed, and that's how I learn that, I can't draw it that way. It has to be drawn this way to help the builder out and the renovator out. A quick example of a wall to foundation with a double brick wall. In this case, we decided to use closed cell spray foam as the transition from the wall system above to the basement wall, which also had foam board insulation. So again, they chose to use a foam-free approach above grade, but then decided to use spray foam below once the reality of what it would take to make these transitions came to be. Another example of the air barrier in this case had to transition and be sealed to the subfloor, which is then sealed with spray foam and continues down. There's no way to get that through as an air barrier system, maintain its continuity down through the basement without transitioning it through the subfloor in this case. So there's lots of little details that need to be worked out, but it's really a good idea to draw them out in this type of detail before you start construction, so you really understand them.
This
And
is
just last example of a foundation or wall to foundation. In this case, this was for a project in the Arctic that had a raised floor on piers, so it didn't have an actual basement. And some of the details here, bringing the exterior insulation through and past the floor system. In this case, it was pretty easy to maintain the water control layer and air control layer continuous, but we did have to make sure we kicked that out and had a drainage spot because it was, as well as the air barrier, it was the water control layer. So we need to have a way to drain that water out. So there's lots of interesting details that need to be figured out in these projects. And because each existing house is typically so unique, these details have to be unique.
And Trevor, I think if we summarized and said, you know, insulation on the exterior is always best, right? That's kind of where we'd like to get to.
Yes.
And that's the lowest risk and actually improves water, air, and thermal all in one.
Absolutely.
What I thought was really nice, though, is you're inclusive of all types of insulation. You don't have to be all foam. You don't have to be foam free. You can do either one. And that it's really a question of balancing that aesthetics and access versus the approach. The one question we got, and I wouldn't mind your answer on right now, what about on the double wide, triple wide brick, putting a sealer on the outside? That is, there's this idea that I can do the insulation from the inside. If I sealed the brick, then I don't have any water issues. Your thoughts on that?
Right. So the history of sealers on the exterior is that they work in the short term, but they don't work in the long term to keep moisture out, because these are sort of moving, continuously living and moving systems that form micro cracks. And the water that gets from the face of the wall into the building or into the structure typically happens at small micro cracks, not as much through the pores of the brick as through micro cracks in the system. And so sealers or even paints that a lot of people have tried can keep your walls drier for a little while, but in the long term, they are dangerous because they don't work from a moisture control in the long term, and they always slow down drying to the exterior, which means that those bricks are wetter for longer. So that's pretty scary.
And I think we will move on to others, Lynn, but one last question. Could you insulate both on the inside and the outside? And the answer would be yes, right? Not just understanding the water, air, thermal control layers, putting the control layers in the right location. There was lots of questions or comment about that ratio, 1/3, 2/3, or at least
yes.
outboard ratio. That, of course, will vary by climate zone, and that you would impact by all means. If you said, I want to do some in, some out, then go do that as long as you maintain the ratios. What I think is fascinating here is you said 9 million. There's actually, I would say more than that. Millions of houses that need to be upgraded. We don't want to miss any opportunities. What we know is the technology is there. The details, the aesthetics, the process challenges we get. They're not to be dismissed. But technically, the information exists from the building science community, specifically your work, that would say, yes, we can do this. We can be successful.
Yeah, and from a design perspective, renovations are more challenging than new builds, like a lot more challenging. And so also probably from a construction standpoint, right? Because nothing is as you expect it to be. There's a lot of decisions that have to be made on site. And so it's really important to understand the concepts that you're trying to execute, as opposed to just following like a recipe book.
Yes, but what I want to make sure is when we say more challenging, not insurmountable, right? We want to be positive.
No, absolutely.
9 million houses to do.
No, we should absolutely. This is something we need to tackle. Yeah,
absolutely. Nice job. Really appreciate that. Lynn, did you want to introduce the next segment?
Yes, and I think part of Trevor, what you explained is being able to look at when you come across these houses, the opportunities, you've got the constraints, and where do they cross over in order to give the clients what they want. So I was very quick when I went over the project teams, but one of the great things that we have with the two project teams that are going to be presenting is Chris Smith is going to be presenting about that classic brick scenario. And we're going to be going into the GTA where we have got multiple to go from there. And Peter Darlington is going to give us insights on his progression through the exterior approaches. So we'll kick it off, Chris, with you, and you can take control. And
all right, how's everybody doing? Thanks for having me today. Hopefully I can give a little insight into what we went through here. Just let me confirm that this changes.
While he's doing that, I'll just remind folks, we will answer your questions. Toby's answering some in writing, and those that we don't answer in writing will get to live before the end of the session. We just thought it'd be nice to get right into Chris's presentation.
All right, so, that was great. Thank you, Trevor. Really informative. I think we broke every one of the rules that you went over there. So, I think people like brick, and in a lot of our clients' jobs, having, the double brick construction is what we're looking at. Job sites where we can and don't really want to, I think, from a carbon footprint perspective, knock it down, dig a new house, put it all back together again. So there is a certain, I think, with the spray foam alternatives, sometimes, you have to consider what you're not throwing in the bin as well, as part of that consideration. This house was not done in the standard net zero sort of path. We kind of had our clients at the point that we were at permitting and construction ready to go. I had mentioned, hey, I'd taken this net zero course, and the client looked it up and was like, this sounds great. I would love to do this. And knowing it was a double brick construction house, I was like, great, this is an opportunity for me to see if I can achieve something that has yet to really been achieved too many times. And of course, with equal parts delusion and stubbornness, I think we were able to sort of work our way through and navigate this sort of project. So let me get into the specifics of it. Obviously, it's a 2-story detached, around 3,000 square foot is what we ended up with. 1940s, 50s built Toronto home, as you can see, double brick everywhere, and we were, very optimistic that, we could achieve something with this. We were changing the aesthetic both in and out, new back additions, all brick it ended up to be. Different applications of brick we used, but I think that, they really liked brick, and we tried to sell them on a lot of different things, and brick was still what it was, and we had to figure out the ways to deal with it effectively. And I think, again, with the water migration perspectives and the ideas behind the brick, we did think about these things a fair bit. Some of this construction is brick veneer. Some of this construction is veneered brick tile over top of wood-clad construction. So we're dealing with 3 different types of brick construction in this project, and 3 different ways that we've come to mitigate water infiltration and obviously water migration. Not to mention insulation and air sealing. So as you can see, there's the before. We're still sort of in some construction stages. Here's the after. Lots of windows, big openings, a lot of, this front of the house, actually part of the 50% walls remaining, we had to actually reclad. So the interior wide of brick is still remaining, and this is a new brick on the exterior, but the sides of the house have both the interior and exterior wise still existing. Obviously, our project priorities were get that 1.5 air changes, the 50 PPA, get some interior heating and cooling. I think that the client's request, and I think the goals that we set out with, was that it had to be easy for the client to control. We did not want something that needed a massive changeover every time the seasons change, because nobody's going to do that. And it's just going to really sort of, I think, implicate the house in a bad way over time, because that's just, and then the other thing was reduce the sound. This project is located at Yonge and Davisville, directly across the street from where the subway just hits into Davisville Station. So roughly every 10 to 15 minutes, you can hear the door chimes, everything. And through the old house, it was pretty loud. So it was like you were pretty close to, a subway station, exactly what it was. The various upgrades that we went through, we ended up with a hot roof assembly, 2-pound spray foam through all the walls, R20 ICF in the foundation of the addition, triple pane windows, hydronic in-floor heating, high velocity space pack AC unit, which was definitely worth the money on doing it, because man, did it ever make a difference. Obviously, in addition to the rear of the home, sauna and shower. And then the one thing that I regret doing probably the most was the gas fireplace that the husband really wanted. Like, this actually affected our blower door test. So yeah, it was definitely a challenge. So as I sort of touched on, some of the challenges is obviously we did not go through IDP. We jumped right into, this is what we need, this is our permit, this is what we have. So it definitely proposed a lot of challenges in how we're going to design around something that's already permitted and not really thought about from that perspective. So I was very hesitant that this home would even be possible, given how far along in the design process we already were. Thankfully, a lot of the things that we had already incorporated into our design transitioned pretty well into the net zero sort of aspects of things. So, for example, our interior construction was always going to have a 2x4 partition that was going to go in front of the internal withe of the brick. So that allowance was enabled us to increase the gap between that wall that we were building out of the 2x4s and the internal withe of brick, so that we ended up with a continuous layer of spray foam, as well as the spray foam that had the thermal bridging between the actual studs themselves. It didn't sound like much, but when you're dealing with a house that every one of these walls were ridiculously out of plumb, in every way, shape, or form, not straight. When you start with a 1-inch gap at one part of the wall, that can end up to be potentially 2, almost 3 inches in some other parts of the wall. So this just allowed for a much better sort of coating of insulation. And I think when we actually got things finished and we were testing out the heating and the cooling, it was just absolutely incredible, like how well this insulation, what it changed, like the level of heat that this place retains. Like, I was there the other day, they essentially have the slab running in the basement only. So we have hydronic floor heating on all floors. They're running the hydronic floor heating in the basement slab, and it's heating the house plenty fine. None of the other aspects are even on. And in the summertime, we had a situation where we were obviously finishing off the house. We were trying to keep things cool and dry. So we were running the AC while the painters were working. They happened to cover over one of the actual return air vents, ended up causing the AC to shut down, and it wouldn't work. It needed to obviously be changed out. It had frozen the coil. So what had happened is this was in plus 40-degree temperatures at that time. Everywhere else was boiling hot. The house got left for the weekend. We came back on the Monday and it was still comfortable in the house, and the AC had not run the entire time. To me, that was just the absolute sell on, wow, the triple pane windows, obviously the insulation and the design of a, obviously heating and cooling system. It just really made a difference. I was astounded by that, because we've done a lot of homes where we've done spray foam throughout, made sure that we'd sealed the various areas, and we've never had performance like this before. So I think even though we didn't go through the integrated design process, having those eyes and those skilled sort of participants from the energy advisors and the HVAC designers, I think it really sort of took the home to that next level, and the client definitely appreciates it. So just to tell you what we were starting with, obviously double brick construction. And to say that it was drafty, I think you can see 7 air changes That's pretty drafty. So it was in no way, sealed. Large window openings, which we've already sort of touched on. Our successes in this were just figuring out, and again, when we thought about the migration of water, I think, when you have a double wide brick, you also have an air gap that is between both of those wides. In most cases, that air gap is about an inch thick. We looked at it as if this was similar to a veneer construction. A veneer brick wall would be constructed with a 1-inch gap in front of a wood frame construction wall to begin with. And what we looked at was, if the water was going to penetrate that initial exterior layer of the brick, where is it going to go? Now, with the air gap that was provided originally, this went down to a standard sort of old block wall construction for the foundation. We had underpinned that foundation, which, if in the interior we had left that situation to be, basically the water would permeate through that first layer of brick, travel down, and essentially go to the foundation below grade and then be exited through whatever weeping tile was there originally. We stopped that from happening because obviously when you underpin it, we've now put a concrete blob underneath all of that block work that's going to drain that water. So what we did is we did internal waterproofing everywhere and allowed for sort of weeping holes within that block work at the bottom, just to mitigate that potential of water that could collect over time. We had a lot of experience during that winter when we were framing and dealing with these window openings to sort of see exactly what was happening around. For some reason, exactly what was happening around our windows. And what we noticed is that although these drawings, and I stole this from somewhere online, so please forgive, I didn't get the time to sort of draw it all up. But what we realized is that your biggest problem with any sort of brick construction is obviously that horizontal point above a window. What water migrates above a window, especially in a driven rain situation? So there are two key components you got to think about. Where are you setting that window in the actual brick construction itself? Like, as I'm sure some of us remember from some of our, education in net zero, overhangs make a difference. How far you are set back from a projection makes a huge difference on the performance of how that water is going to be driven into that opening. So we purposely set our windows back as much as we could in that initial withe of brick. So we were getting at least 2.5, potentially 3 inches of setback, so that we could also get a good layer of caulking around the brick to seal the brick. Now, the thing that we really put a lot of thought into is, again, when you're dealing with your steel lintels that are above those window openings or the steel beams themselves, what mitigates the water that comes in from the top and lands on that? And so what we were looking at doing is, in a combination between the two steel lintels in that same air gap, we would put backer rod, but we would try and slope the backer rod by poking the center of the backer rod up and then obviously having it slope down to either side. On either side of the window openings, and this is before the flashing tape or any of that was put in, we sort of just added foam mineral wool insulation only on the vertical portions and some on the lower horizontal proportions where we could. But you'll see in some of these pictures that this was a moving target, because this is a picture of one window that we were dealing with. As you can see, there's just no consistent gap. There's no consistent construction. There's nothing that you can easily stick to. So each one of these windows had to be treated as, let's see how far we can get with just sort of sealing it. We tried original blueskin to start with. It wouldn't stick to half of the brick stuff. Then, the combination of framing, mineral wool, obviously you see a bit of styrofoam that's sort of set in there. What we were trying to do was just give ourselves something that we could seal to, and then when they sprayed the spray foam on the inside, that the two would tie together. It sounds doable, but in practice, it required a lot of sort of back and forth. So our spray foamers had to come in multiple trips, because we would notice that some of the spray foam wasn't necessarily getting to where we would want it to get. some of those gaps were not getting filled properly with the spray foam. So the time of year that we were spray foaming, like we had to get an indirect heater into this building because it was too cold. And the ambient temperature, if it's not 5 degrees, like that spray foam won't adhere properly to any surface. And it's not just the ambient temperature, but it's the moisture content of those materials makes a huge, effect on how that spray foam adheres. Long story short, we were able to sort of get through it, and we did it in a way where once the windows were in and we had our blower door test, and you can sort of see here, it was combinations of half-pound foam in some cases, because we were like, we still wanted the permeance of half-pound foam because of the fact that, like, if any moisture got in there, we wanted to be able to, like, at least have the ability for it to dry, because we've maintained that air gap all the way through the building. So even in our brick veneer construction, the air gap ties into that double wide brick construction air gap. So the air gap is followed all the way around, which we felt was something where at least it would give that ability for any moisture to have a chance in hell of drying. So that was, again, our low-tech version. On the interior, so you have 3 pictures here. One picture where you'll see, wow, that's a lot of purple foam. It's not really about the purple foam. What it is about is this is our 2x6 construction and our brick veneer. So this was the rear addition of the house. What you'll see in all the white lines that are on there is that's all the caulking that was put in between literally every joint that was possible in any of our wood framing, because each one of those joints was a potential air infiltration because of the gap that we had to maintain with the brick veneer construction. So even our air barriers that are being put on top of our framing still weren't going to be enough when you have sort of an air gap that is allowing stuff to get around your construction. So the middle picture is showing you what we had to do for the second floor, which, I think maybe if you remember in the first couple of pictures, there was an overhang. There was overhang on the second floor rear addition on both sides. I might be able to go back to that. Bear with me. So there's an overhang on both sides of this addition. So obviously this brick can't actually be brick without introducing some massive steel structure and, again, some assembly problems. And so what we wanted to do was we wanted to explore the options of, like, if we ever had to do this again and people do want brick, how difficult is this to do in a brick tile / veneer? So these are slices of brick. So this now just becomes an external cladding on cement board. So now we're able to seal and obviously insulate. We have R10 continuous on the outside of this, sealed properly, every air barrier, everything, and we still have brick. And it looks exactly the same.
Isn't that trying to manage that aesthetic, right, Chris?
Trying to manage the aesthetic. Yeah.
Right. And this was some great detailing there. We'll just watch our timing a little bit, but I really appreciate how you've met the thoroughness of the concept of maintaining the air barrier and still maintaining that aesthetic. That's wonderful.
Yeah, it wasn't easy, I'll tell you. Definitely, again, not by design, but just through sheer stubbornness. Because the other little caveat was that when we did our blower door test, we were already well into finishing. So I had to be damn sure that this was going to actually meet the requirements. And, we're still to be determined. I think we were at just 1.8 the last time or something like that. So we're close, but it hadn't, like, we tested all of our windows, all of our openings. There was no smoke, no nothing. So every opening was sealed, and that worked fantastically. The things that did have it was a skylight that was installed by others, and we got them back to fix that. A fireplace, which, again, I didn't even think of at the time was going to be a problem, because we figured, well, you have a fireplace, so obviously it's just the exhaust point for the fireplace. No, because the actual fireplace construction itself, it's not sealed. Like, it's a sealed unit for the burner, but there's still a bunch of stuff around. So we figured that one out as well. And we had a bit that came in around of our electrical panel. But beyond that, I would say it was a massive success. And, the homeowners are super happy that they were able to maintain their brick, veneer, their brick aesthetic. And they really, really did appreciate how well and how quiet the home is. I cannot stress more that beyond all the net zero stuff, this home is just vastly better.
And I think that's that important theme, right? The whole premise of CHBA doing this series is for the 480 people on this call. You might think this is about energy. It's not about energy. It's about sustainability of houses, safer, healthier, more comfortable, more durable. Oh, and by the way, also meets Canada's energy efficiency goals while maintaining that aesthetic and finding processes that work. I like too the tie-in, and I see it on lots of the comments. So you can't insulate till you make it airtight. Well, you need to make it airtight while you insulate. Then what does that do to ventilation? That's why there's 5 segments to this series. Airtightness last week, you've brought it in again, and then we'll talk about ventilation in future ones. Chris, thank you. I always love to see that enthusiasm. And congratulations on great progress on that project.
Thank you. Thank you. Appreciate it. Thank you for your time.
And Lynn, you wanted to introduce our next speaker?
Yeah, the attention to detail is throughout all of this, and it's the stacked benefits. But from Chris's experience going into this and having those lessons learned, we're going to hear from Peter Darlington, who was our very first net zero renovator through our labeling program, and has that longevity of rotating through different experiences, fine-tuning. So we're going to hear all about that evolution from somebody who's been doing this net zero performance for longer than anybody. So we'll let Peter take over control. There we go. You should be good.
Go, Peter.
Perfect. Thank you. I don't seem to have control of the screen here. There we go. Good afternoon, and thank you for joining us in the Towards Net Zero Renovations Above Grade Walls webinar. My name is Peter Darlington. I've been putting building exteriors together for 30 years. I started my first company at 21 in the year 2000, shortly after dodging the Y2K bug, and only hours after spending 3 months hitchhiking through Western Europe. I've had the same phone number for 30 years and have only ever gotten one call for a leak that was my team's fault. Kelly, my right hand, has been with me 25 years, Justin 15 years, and Matt and Ian about 5 years. We have almost a century of combined experience on our team, and putting these wall assemblies together takes a team mentality. Today, I will present on the evolution of wall assemblies for solar homes on wood frame homes. Solar Homes was incorporated in 2015, which was shortly before I joined the CHBA Net Zero Council. I now sit on the CHBA Net Zero Management Council, Technical Council, Version 2 Working Group, and the Net Zero Reno Working Group, as if having 2 young kids and 2 companies wasn't enough to keep me busy. Solar Homes labeled their first net zero renovation under the CHBA's pilot program, which happens to be my family's home. We love the house. It's comfortable, has great indoor air quality, and 0 energy bills. I still don't seem to be able to advance the slides.
If you click with your mouse, no?
Was working in the practice, but there you go. But you don't get there without doing some research. Hopefully today I can cut down the learning curve for a couple of you out there. If you want to check out RDH's cladding attachment guide, it's a very useful guide and I highly recommend checking it out. But Cole's notes is that how you attach your cladding has a huge effect on its performance. So don't think just because you put 6 inches outbound insulation, you're going to get an effective R24. If you install continuous vertical Z-girts, which would be worst case scenario, your effective insulation value can suffer up to a 80% loss. So that was a big waste of time and money. In our net zero renovations, we're usually working with pre-1990s homes with 2x4 construction and are usually aiming for 6 or more inches insulation outbound of existing structure for a total effective R value over 30, which is a dramatic increase from the existing effective R8. Air tightness is just as critical as insulation. Think wool sweater full of holes, not very comfortable. Another great resource is Enercan's Keep the Heat In, which was the inspiration for the box beam wall assembly, which I'll present later in this slide. Of course, cost versus performance must be considered. I'm going to talk about 3 main assemblies Solar Homes has used and one that we're just starting to try out. We've done more than 5 single detached homes with the first 3 of these assemblies over the years, so it's not just theoretical but real world experience. The first will be EIFS, or exterior insulated finish system. The second will be rigid mineral wool with strapping. The third, a box beam based wall with blown in cellulose. And the fourth, a modified Larson truss assembly with dense packed cellulose. I will discuss what I've seen in costs, availability of labor, complexity of tying in attics and penetrations, and some general advantages and disadvantages to each assembly. All installed costs will assume demo has been done and you have a clean, ready to go substrate. It also assumes a relatively simple building form, as complexity of building will dramatically affect square footage pricing. But cost is not the only consideration. If these retrofits are too complicated for others to pull off, then scaling takes too long. Our goal at Solar Homes has always been to figure out how to put a wall together in a simple way that is easily scalable and effective. First up is EIFS, which is a rigid EPS, or expanded polystyrene, which is glued over top of a liquid applied air barrier. Do not use screws to install the foam. You then sand the EPS smooth, install a fiberglass mesh embedded into an acrylic base coat, and then an acrylic color finish coat. It can be shaped into any shape you can think of. It's lightweight. It comes with a full set of CCMC approvals for easy permitting, and it is truly thermal bridge free. We started installing EIFS in 2005 or so. Over the past couple decades, we've probably installed EIFS on close to 100 homes, both new and renovations. When done correctly, all materials come from a single supplier, Stowe being an excellent supplier, and comes with a 12-year warranty. The system can be designed with a varying amount of drainage behind the insulation, from 1/8 of an inch in drier climates to a full 3/4 inch rain screen in wetter climates. Unfortunately, EIFS is susceptible to woodpecker damage. In the past 5 years, Calgary has seen a dramatic increase in the amount of woodpecker damage. Of the 100 or so EIFS homes we've installed, we've only had 4 or 5 get hit by woodpeckers. There doesn't seem to be any rhyme or reason to which houses they'll hit, but when you get a customer calling about a bunch of holes in their house, it is not a very pleasant conversation. It is possible to add a woodpecker coating to the assembly, but that adds significant cost. When Solar Homes first started operating, EIFS was basically the only cladding available that could be used in residential retrofits effectively. It is a great product, and if woodpeckers are not a concern in your jurisdiction, I highly recommend it, especially if you can find a skilled installer. And just to pick up on Gord and Trevor's points about aesthetics, a skilled tradesman can make EIFS look almost exactly like brick. Costs can range from 15 to 30 bucks a square foot, but that is a completed wall with no further costs associated. Materials should be relatively easy to find, and if you're short a bit of material, you should be able to get some in a reasonable time frame. Your contractor will probably have to pre-order the 6-inch foam, but EPS is a relatively common material, and lead times are usually not too bad at about 2 to 4 weeks. The rigid mineral wool wall assembly consists of a vapor open air barrier followed by 2 layers of 3-inch mineral wool and then vertical strapping to support the cladding. We started using mineral wool a few years ago when we came across a home that was inside of the 4-foot lot lines and required a non-combustible wall assembly for permitting. This particular permit was a real challenge that ended up taking months due to having walls with windows inside of the 4-foot line. We argued that we were making this home significantly more fire resistant, basically wrapping it in a fire blanket, and eventually got our permits. It is nice that some of the suppliers of the mineral wool have engineered drawings indicating screw spacing for various cladding weights and strapping materials. However, with this wall assembly, you are dealing with many different suppliers, and so a single system warranty is not available. Another challenge with this assembly is the fasteners themselves. You have to run an 8-inch or so thick screw through your strapping, 2 layers of mineral wool, and then catch the stud in the wall behind. From a practical standpoint, that means you have to mark all of your studs as you work your way up the wall, accounting for jogs and framing at window openings and floor lines. As you can imagine, misses happen, and then you can't back the screw out or you'll leave a hole in your waterproofing/air barrier. If that wasn't hard enough, you also have to set the depth of each screw exactly the same, or all the strapping will not be flush, and then your cladding will be wavy.
Peter?
Yes.
We had a question earlier exactly on this topic. Would you say there is a maximum amount of foam board or mineral wool that you would want to install in the exterior of a home for this cladding, this attachment reason?
Certainly 3 inches would be easier to install. You'd have less movement on your screws. But from our perspective is if you're gonna go this far and rip these buildings apart and rebuild them, the actual installation itself is not that expensive. It's taking apart and putting it back together that's really expensive. So our mantra has always been put at least 6 inches of insulation on the outside of these buildings.
At least 6 inches. Okay. And that can
That
be
has
done.
been that's what we like to do. And then you
Okay.
get these heat demands super low, down to like sub 20,000 BTUs at -30.
Okay.
Nice.
So in this webinar, I'm not going to talk about window returns, attic transitions, or penetrations a whole lot. I'd need a lot more time for that. But I would say that with mineral wool, it can be a bit more challenging, all the returns. This assembly does take skilled carpenters with a lot of patience. But if non-combustible is important to you, this is the only wall assembly I'm aware of. Costs somewhere around $35 a square foot, depending on your jurisdiction, but that's without cladding. So you add some more money to that. Long lead times on mineral wool are common. We've waited up to 6 months for ordering our mineral wool. Sourcing 8-inch screws is not always easy, and if you run short of either of those materials, it can be a significant delay. Again, this is a highly skilled, labor-intensive assembly and takes longer to install. And it can be quite frustrating when trying to catch studs, especially if you forget to mark a couple. As mentioned earlier, the inspiration for the box beam wall assembly came from Enercan's Keep the Heat In. We were actually already into a customer's project where he found this detail and let us kind of change our plan and went with it. It's basically a box beam secured to the foundation with 2x4s run from the box beam up to and attached to the existing truss overhangs. We use 2x8s for the box beam, which leaves completely thermal bridge space behind the 2x4s that run vertically. We did have to engage engineer to do a full set of drawings for this assembly. Engineer drawings were a requirement in the permitting process. It cost quite a bit for the first set of drawings, but going forward, the details are mostly the same with a couple of site-specific tweaks, but basically the engineer just puts a new address on the drawings already done, minimizing permitting costs. A nice thing about the way we've drawn it is that the weight of the cladding can either be supported by the box beam at the bottom or the trusses at the top. So when you come through windows or other openings, you don't need to figure out load support. We typically use a self-adhered vapor open membrane on existing sheathing for air barrier and a moisture control, such as a Tyvek or equivalent, outside of the dense pack to keep the cellulose dry. We have installed the walls without removing the old cladding when we were faced with stucco containing asbestos, which was quite nice. It's extremely convenient that all the materials for this assembly are very easy to find. They're all common framing materials that have the added bonus of being carbon sequestering materials as well. I think this build has very high potential for scaling quickly. One crew does all the demo and air barrier. The next crew does all the framing, then insulating and cladding. Nothing too tough, just common building practices. Costs are pretty much in line with the other wall assemblies. However, this is a 9-inch wall for R36 instead of the other, which are 6 for R24. As far as timelines, I think there are no special considerations as far as material supply or permitting go. This can be pulled off pretty quick. We just finished the above grade walls on a 30 by 40 bungalow, complete with cladding and rainwear in under 4 weeks. Modifying Larson Truss is a new wall assembly for us, and we're just getting started on our first project. It consists of a 2x2 nailed to the existing studs with pieces of 1/2-inch plywood gussets spanning to another floating 2x2. This cavity is then filled with dense packed cellulose. Very similar to the box beam from a supply and install perspective, except that existing cladding must be removed for this install. Also, whenever nailing or screwing a material to existing framing, there's a risk of hitting electrical lines, which sucks. Something I like about this assembly versus the box beam is that the box beam assembly has a bulky base, which usually gets attached at or near the floor joists, which is also where the bulk of penetrations exit the home. That means that you have to have all your penetrations prepped for the thicker wall before you install your base plate in your framing. With this wall, there's no bulky base plate, so you can build your wall, then you can mount all your new penetrations to the outside of the new wall. I think once you get into multiple stories, this assembly may prove to be better as the load is transferred back to the existing walls of the building and no additional reinforcement or detailing is required at floor lines versus the box beam assembly. Again, all materials are easy to source, inexpensive, and carbon sequestering. Costs are pretty much in line with the box beam, very similar assembly. I believe Net Zero Renovation is the pinnacle of indoor experience. You have excellent air quality, great thermal comfort, dramatically reduced operating costs, and you knock your carbon footprint way down. We take homes that are in great locations and without demolition and rebuilding at high cost, we deliver better than new build quality. These homes are also incredibly resilient. In Calgary, the major risk is hail, and we incorporate hail resilient strategies into our builds, which includes Class 4 shingles and hardy siding. Even in the case of power outage, these homes take a long time to go cold. We had a situation a couple of years ago where the transition from heat pump to resistance heating didn't quite work, and at -30 over 24 hours, the home only dropped 4 degrees. Unfortunately, these homes can also form some bad habits. I like to walk around in a t-shirt and no socks when it's -30 outside. I like to keep our home within a degree of 19 at night and 21 during the day, 365 days a year. And I notice smells and cold spots in my friends and family's homes. When I started my net zero journey a short 10 years ago, I had no idea where it would all go, although I thought that this was inevitable. And here we are today with a couple hundred of Canada's brightest leaders investing their time to learn how to do these high performance homes. I wish you all luck and thank you for your time.
Peter, just go back to the one slide. Go back one slide if you wouldn't mind. I just thought that was just to folks maybe not as familiar with the Larson Truss, and they might want to just dwell on that just for a moment as we finish up. Fascinating to see somebody's gone through that derivation. I love what you said. There's a lot of research that went into this. There's been technical research. You mentioned RDH and others. And then you're kind of right back to where the industry years ago, Harold Orr, Rob Dumont talked about the chainsaw retrofit and, basically a building a wall to the outside. I thought that's pretty fascinating. Not that those other systems can't or don't work, but that in fact, we need perhaps multiple solutions. And the fact that you've had experience with all of them is so powerful for everybody. Thank you for that.
And when you look at the material and we look at cost effectiveness, you're looking at about as good as you can get with in terms of that standardized material and lumber that is easily accessible, as you mentioned, Peter.
Fascinating. Thank you. So you can move on if you wanted. That's fine. I just wanted to just highlight that one more time. Again, thanks for your experience. That's cool. Toby, were there any questions specifically for Peter before we go to?
There are a couple questions here. Yes. One of the interesting ones is how are you when you're using a thick exterior mineral wool insulation, for example, How are you attaching cladding at corners?
Mm.
I guess when you have the mineral wool, butting up against each other.
Yeah, so when you attach at the corners, you run your strapping horizontally or vertically, depending on what cladding attachment. And then typically you'll build like a 4-inch wide corner piece that will secure to those horizontal girts or whatever you've used for support.
Okay. Okay.
But yeah, you can't really stick like a very small corner detail, outside corner detail on some of these systems.
And I see that you have tried blown-in cellulose in some of the walls. Have you ever tried a wood fiber insulation, I guess, instead of a mineral wool?
We haven't. Again, it's kind of being able to source the materials. Admittedly, it's been some time since I looked at wood fiber material, but it used to all come from Europe, shipped over. I think there's a company in Canada making a 2-inch thick board, but we haven't found anything locally available in the kind of thicknesses that we're looking for
And
Okay.
at a
Meredith may
cost-effective
wanna-
point.
And Meredith wrote that comment and she may want to put in where her supply is coming from. There is a Quebec company, there's a Maine company now that are doing wood fiber that we're aware of. So availability is pretty interesting. So thanks for that.
I think dense pack cellulose is going to be tough to beat. Like it's just so cheap. The material itself is like dirt. You pick up a bag for $12.
We have struggled nationally with local supply. Some places it's quite available, other places there aren't good applicators, or at least there's a lack of applicators in some markets. So I understand that. That's great. There we go. And next was questions. So Toby, where do you want to start?
We do have a couple more here, I think specifically to Peter. And then if no more come in, we do have a couple, I think, from Trevor's presentation too, that we can go back to.
Yes.
Peter, Paul is asking, or it's more of a comment, I guess, but maybe to your experience, have you ever considered using, so when you're using a thick mineral fiber or mineral fiber insulation, and you're having a hard time hitting the studs with your screws to attach that, have you ever used 5/8 or 3/4 inch, I guess, plywood sheathing that you could then attach to?
We did consider that on one project. We were thinking we would actually run 2x4s right on the building, and then we'd put 1.5 inches of mineral wool to come flush to the 2x4, and then another 3 inches outbound of that. But it just started getting so complicated that I think we were kind of about to throw our hands up at this kind of wall assembly,
Okay.
and any kind of further investigations from our perspective were going to be kind of waste of time. But we did look at trying to do something but we never effectively pulled it off.
It seems to limit the amount of insulation you can add to the wall versus the box.
Yeah, and then you would still have that 2x4 or whatever you.
You lose some insulation value there. Yeah. Question from Gary Hamer. Is there any problems with using EPS insulation in fire-prone areas?
EPS is not fire rated. For EFIS, you can use a rigid mineral wool as a substitute for EPS for non-combustible assembly.
Okay.
There's been some good work there, Peter, with one of the manufacturers has done some good work as a stucco, mineral wool as a stucco base, that there are now good details for that. That's great.
There were a couple of questions on the carbon aspect, so operational and embodied carbon. And I know the foam question came up, and some of the manufacturers are working very much on their accelerants and reducing some of that impact considerably. But one of the things that we did on the Towards Net Zero Reno project is every project was funded to do the material carbon emissions estimator, or they could alternately use the beam tool. And Toby, this is where we also kind of put that onus on the net zero energy advisors to help facilitate that. But that is something where, just like being fuel agnostic, it would be also wall assembly agnostic in terms of managing when you're looking at that, Toby, in terms of managing the performance levels that you need with the building science interactions of what's existing, and then also looking at that carbon impact. How did you find, also from your perspective and engaging with our EAs across Canada?
Yeah, so we found not all projects undertook this exercise, but a lot of them did. The ones that I am most familiar with are in Ontario, and we did find even using a spray foam product, whether it's for part of the assembly or the whole assembly, does the embodied carbon involved in that is offset by the savings quite quickly. So within 2, maybe 4 years, the operational carbon savings are more than the additional carbon you're putting into that assembly. So it has kind of a payback of the one project I worked in, it was a 2-year payback. They used, I think they just used a couple inches of spray foam, and then the rest of the wall, interior of the wall, they built out with like a mineral wool insulation. So that had a very good carbon payback. Granted, that's in Ontario, which is probably sort of a moderate grid compared to the rest of Canada. There's grids that are dirtier, so your payback would be might not be as good.
Well, from an operational carbon, if the grid is dirty,
You're
yes,
right.
the more savings you get. So
Yes. Yeah.
I'll just reiterate that, Toby, and thank you for that. I always, of course, defer to Chris Magwood on this as to what should we be doing, and he used he'll correct me if I'm wrong, but if I misheard him, but he said, obviously the carbon we save today is more important than carbon later, but still, anything that shows a 6 to 10 year, I'll call it return on carbon invested, is worthwhile. And our experience has been triple glazed windows make sense. I did one in North Carolina, a model. Triple glazed windows, even in North Carolina, made sense. And we've found that the amount of insulation, we go back to Trevor's comment about getting to at least that effective R value of 18, the amount of insulation you need to add, the material choice you make, all of them would still have, to Toby's point, of a return on invested carbon of less than 5 years. If you were looking for extreme amounts of insulation, 8, 10, 12 inches, then you'd redo. But certainly to get to the levels of, let's say, even up to effective R25 in our new house work, we would say you're seeing a good return on carbon invested, less than 5-year return on carbon invested. So hopefully that gives people confidence, while by all means use low carbon products. Don't, if the application calls for from a process, cost, access, whatever, then don't be afraid to use a higher carbon insulation material.
And I think that's part of the conversation that we've been having, is that system, how that whole system plays, and it's
Right.
got to have that flexibility, because the craftsmanship and the attention to detail is what matters, and sometimes you need that from different products depending on your existing conditions. And I know Chris, working with your existing conditions in the middle of Toronto with limitations there, but a lot of it also goes to the stacked benefits. So it's actually, and we talked about this before, Gord, the intentionality of planning that out in terms of not just the roadmap to net zero, but also the implications. So, that higher price now, cost-wise for upfront costs, but also perhaps on that embodied carbon, because we're looking for the long term. And Chris and Peter are renovating and revitalizing our existing housing stock for the next 100 years. So we're looking at that perspective of making sure that, we're not, what's the expression, cutting off our nose to spite ourselves, where we may undo some of that longevity by not giving ourselves the full spectrum of what's available. And those stack benefits, that's something that I think also is part of what we've been talking about through this project, where we're talking wall assemblies, but the reason why we are doing this is for the benefits to the occupant, and it's different ways to get there. Can I ask, just with Chris and Peter, for a quick commentary in terms of that conversation with your homeowner, in terms of translating these various wall assemblies into occupant benefits? Chris, we'll start off with you.
So sorry, for the clients, like how to convince them that these.
How to actually translate, this is what this wall assembly will give you in terms of performance inside the building, your indoor environmental experience, structural and health, and all those sort of different implications.
Yeah, I think that's probably one of the most challenging parts, because people don't really think in those perspectives. You know, like I find that clients are more tactile with everything, and I think that having that comparison to, you know, especially with most of our clients having lived in their home for a fair period of time, it's having that the first time they've walked into the house once this stuff has been done. Obviously we go through all of the details, we explain everything, we show them all of these are the energy values, this is all of it. I don't think that they really buy into that, other than in the most general sense. But like that story that I told you about the air conditioner situation, they were the ones that walked in there that Monday, and they felt the fact that, wait a second, it's 40 degrees outside. They knew that the AC had not been on for the entire weekend. Nobody had opened a door, and the house is still cold. And that right there, they were sold 110% at that point. And I think it's the real world translation of what we're talking about. Like, obviously we geek out on all the science and the building strategy and everything, and I think people from a generalist perspective obviously appreciate it and they understand it. However, it's when they have that point of comparison. And I think the more of these points of comparison we can provide for the average homeowner, because remember, it's not just them that's going to go through and experience it. They're going to tell somebody about that. I know that they've told that story at least 20 times to friends and family. And it's just because those are the type of things like, wait a second, 40 degrees for an entire weekend in a house that's made of brick, and all of a sudden it's still cold. Like, that's, you know, I think it's that sort of stuff. And I think if we can work on trying to get as many of those stories out there, I think it's a success for sure.
I think
And
you know, Chris, that people become accustomed to their own house and make compromises in their lives without even recognizing they made those compromises.
Absolutely.
It's not until you've taken away those, they go, oh, you mean I can use this room in the winter? Yes.
We
The
make
basement
do.
doesn't have to be dingy. You know what? It feels exactly like the rest of the house. What? How's that even possible?
Yeah,
To
it's
Winston
incredible what
Churchill's
we
quote,
make do. And that's one thing that Peter did, to turn to you, is that those intangibles of that experience of a net zero home, because you brought your own home to net zero, having that lived experience, being able to convey those intangibles to clients of what it feels like, because that's what I've been hearing also from people who have lived in these homes. It's like, this is the way I want to live. This is what I want in a renovation.
Yeah, it is super hard to describe. How do you describe what a heated car seat feels like? It's just like being wrapped in warmth. And, you know, I sometimes get kind of technical in saying that if your insulation's outbound, then your studs, your drywall are all going to be warm. Everything inside your house is warm. You don't have that, you know, 5-degree outside wall, so you're not being constantly fed that cold air. So yeah, and then a lot of our customers come through word of mouth, where they've been into somebody who's already had one of these retros, or they're friends of somebody that's had one of these retrofits, and they've just experienced how nice it is, how quiet, how crisp the air is.
it is
Tough to
fascinating.
explain.
That consumer dynamic, it's well,
And that's part of, like, Gord, to that point, like in terms of that consumer, is that what we're finding is that homeowners don't even know they can ask for this. And we want to empower that once they're aware that they can ask for this, that we can point them to people who can deliver on this type of high performance.
So are you saying webinar 6 of a series of 5 is on how do I sell this stuff? Yeah, perhaps.
That will always be a
Yeah.
need. Always, always.
I would
I do
say
feel
it
the need
sells
because we're-
itself.
Yeah, exactly. I do feel the need. We have a couple of more technical questions around the fasteners. Ken asked what type of fasteners are you using for 6-inch plus the strapping, are the GRKs, and what's the cost? And I think all three of Trevor, Chris, and Peter talked about, yeah, fasteners are tricky. And then who's speccing the fasteners? Do you need a structural engineer? Peter, perhaps you start because you have perhaps that you've tried more things than anybody.
Yeah, if my memory serves, the supplier, the mineral wool, in their spec sheets will have a gauge of screw required. That can be a GRK. There's a bunch of different brands out there. I think what's kind of more challenging is getting the exact depth that you need. So in
Right.
the one slide where I had 6 inches of mineral wool with steel strapping, that requires about a 7.5-inch screw. Good luck. You probably find an 8-inch screw somewhere if you look hard enough. If you're putting 3/4-inch plywood outside of that 6 inches of mineral wool, then maybe you need an 8.5-inch screw. Again, you're going to find a 9-inch screw. But there's a bunch of different companies out there that will supply screws to you. It just takes a bit of finding and then some lead time to get them on site.
And Trevor, I think that's part of your world, right? And the work that you've been doing up north is getting the proper fasteners.
Yeah, specifying and really trying to work with available materials and available fasteners and trying to simplify the design as much as possible.
And I didn't know we were going to do bird watching today, but does anyone have a woodpecker solution for wood siding over rain screen over exterior insulation? That's interesting. He's asking, does anybody put sonarboard over the strapping behind the cladding? I don't know. Anybody have any thoughts?
All I know
cladding.
is I was woken up by a woodpecker pecking on the top of my neighbor's steel vent for his fireplace. So I don't think they're real picky at what they attack.
Fair enough. Other than that, Kim had a nice comment that Chris, whether he knew it or not, had run an IDP because of his interactions with the client and all the conversations you've had that have affect. And I, if it's okay, I'll just do it. Again, my impressions of, and I just really appreciated the inclusive nature of this. We've got 9 million houses of a bunch of different configurations. Technically, I would say the science has been done, that technically we can get this done. Air, heat, moisture flow. Each one of them has the challenges. There are materials available in all cases. Then we have to work through, and Peter and Chris, you both did, and Trevor did a really nice job of indicating it's all about the details and thinking it through. So we don't want to dismiss the details as being challenging, but it is possible. And indeed, it's imperative that we not miss an opportunity. That's really the point for the 480 people who came on this call. Hopefully, we're coming to this call to say, is it possible? And what I love is that you folks were able to show it is indeed possible, and you can determine your own level of how practical or how challenging it is. But clearly, this has been done in Lynne 350 projects across the country, showing that this is absolutely possible. So I'll add my thanks. I know others want to perhaps make some final comments, but technically we can get this done. And now it's up to us to in fact make that happen.
Absolutely. And I think part of what the message that we have is that it takes a team, and whether you have a formal integrated design charrette or it is just your process. And Chris, it sounds very much like it's your process to be engaging all the team. And that's how all of this work happens. So I'm just going to also do a plug right now. It is November. I just found out that we've got a brand for that. So when we talk about improving our enclosures, we talked about this with our air tightness webinar. We are in the best season for doing radon testing and monitoring. November, when you're in your heating system season. So go to november.ca, get your kits, talk to your clients, and just giving a shout out for that as we go through this. We will be sending out resources that we've talked about. Trevor, we're going to include that link and hopefully that document on RDH's building, but also our CHBA Renovators manual. We have also rebates on our net zero training, on our online training that are currently available. And last but not least, we do have the next three webinars coming up. So heating and cooling, right sizing. So once you've got your enclosure, that whole combination of conversation has to be integrated. And so we're going to be talking about that next on November 27th. And before you leave, I'm going to leave this up here while others make any final comments, but please complete the survey. It is an agile process, and we take your comments and feedback and apply it to the next webinar. So if there's
I'll just
any,
say there's a link in the chat for that, Lynn.
What's
Just
that?
well, there's a link for the chat.
Perfect.
A link in the chat if you want to click on the survey.
Excellent. So I do want to extend my sincere thanks to Trevor, Gord, Peter, and Chris, and Toby for being here. This is part of the narrative, is that, yes, the science is there. The science is pretty constant. How to apply it in our existing housing stock needs some teamwork, needs some sharing of ideas. That's what we're here for. So I hope you enjoyed today's webinar, and we will see you all on the 27th. Thank you.